In a two-level system like we've been considering, it's actually impossible to make a population inversion. Because if we do generate extra molecules in state 2, they will go back down to state 1, and there's no way to get excess molecules in state 2. So to make a population inversion, we need at least 3 energy levels, and often we use 4 to create a laser. So we'll look at both of these examples of either the 3-state or 4-state system. So the 3-level system, the idea here is we have our ground state, what we call state 1, and we have an excited state. We have 2 different excited states, states 2 and state 3. So the first thing we do is we pump molecules from state 1 to state 3. We have some way, and there's, as we'll see, there are multiple ways to do this, some way of getting our molecules into the excited state. And then we have some sort of fast relaxation process that happens here between state 3 and state 2. And state 2 back to state 1, this is our lasing transition. And this is, relatively speaking, slow compared to the transfer from 3 to 2. And so what happens is we try and get all of our molecules, or as many as we can, from state 1 up to state 3. They'll very quickly transition to state 2. Right, so we can imagine our molecules start in state 1. We pump most, right, so maybe we have a bunch here. We pump most of them up here, and we have a few left over. And very quickly, these molecules move into this other state, and we still only have a couple of molecules left behind in state 1 because we pumped most of them up to state 3. And this, we get our N2 is greater than N1. And we can achieve our population inversion and get stimulated emission of radiation being our dominant process in this. All right, and so this is what leads to our population inversion. We can actually create a laser. Now there's a variant of this, and probably is more common than this 3-state system, is a 4-state system, but with a similar idea. So in the 4-state system, we're still going to have some sort of pump process here. So this can either be done with light or with electricity, or there's different ways of doing this. And again, we rely on a fast relaxation here. We'll call this state 3. And then we have another state 2 here. This is where our lasing occurs, because we want N3 greater than N2. And then we also have another fast relaxation process here. And so the idea here, this is a little bit easier than the 3-level system, because even if we don't pump everything out of state 1, which is down here, we can still achieve a population inversion, right? So molecules will quickly go up here and relax down to state 3. And there won't be any, at the beginning, there won't even be any molecules in state 2. So we'll get N3 greater than N2. And then as soon as molecules the stimulated emission process happens and they jump down to state 2, they very quickly go back to state 1, and we can start the process all over again. And so both of these are cyclic processes, right? Our molecules will cycle through all these levels very quickly in rapid succession. And so it's a little bit easier. This 2-to-1 transition right here makes it a little bit easier to achieve our population inversion and achieve lasing. All right, and so in the next video, we'll talk about what are the consequences of this, and why is laser light so useful? Why bother going to the trouble of finding systems where we can do this?